allow me to give you a few other interesting points. Light travels at about 186,000 miles per second. This is called the speed of light. This is a reason, for example, when you see a lightning flash, you see the light instantaneously. But you start to count 1001, 1002, 1003, and so on, and then the sound arrives, because sound travels much slower than light does. At the speed of light, the sun being about 93 million miles away from us, the light from the sun takes about 8 minutes and 19 seconds to reach us. Which means this: if the sun burns out, and don't worry, it's not going to do that, at least not anytime soon, we have 8 minutes and 19 seconds. That would be kind of a cool name for a movie, don't you think so? Or a book? The moon, because it's significantly closer at about 240,000 miles out, has light bouncing off of it that takes about 1.5 seconds to reach us. So obviously the moon is much closer to us than the sun is. At the same time, Jupiter, which shows up in the sky frequently, has light coming off of it that takes about 37 minutes to reach us. So look at those three objects: the sun, the moon, and Jupiter. Obviously, Jupiter is significantly further away from Earth than is the sun. Remember that picture I showed you of the Milky Way galaxy? When you're looking into the middle of the Milky Way galaxy and you're seeing the light from those stars that are in the middle of the Milky Way galaxy, that light took 26,000 years to reach us, traveling 186,000 miles per second. The universe is vast. So when you see the light from those stars, you are looking effectively into the past, because that light took 26,000 years from the center of the Milky Way to reach us. Whatever was going on there is over. When I was in high school, in the beginning of college, the United States sent up 2 spacecraft, Voyager 1 and Voyager 2. They were traveling away from this planet at 17,500 miles an hour. Basically, their job was to go out and explore the outer reaches of our solar system. So in other words, Saturn, Neptune, the moons that are out there, even Jupiter, which is not as far out. When I was in college in the late 1980s, Voyager 1 and 2 were passing those outer planets, and we were getting the first really beautiful, high-resolution pictures of those planets and their moons. In fact, this is when they figured out that the rings of Saturn are actually multiple rings with all of these things inside of it. They had actual photographs of it at that point, and that other planets, the outer planets, had little rings going around them as well. Well, I was having dinner with a friend of mine who works for Caltech in Pasadena. He's a German immigrant. And we were talking about these 2 aircraft, these spacecraft. And I asked him, because these 2 spacecraft long ago in the 90s left our solar system and are out now, flying way out past Pluto, going 17,500 miles an hour. Do we ever get any information from them anymore? And he told me every now and again, there'll be a little beep, like, I'm still here. We aren't getting any information from them, but they're still viable objects flying out. And so the obvious next question is, well, where are they going? And he told me they're headed to the nearest star, the nearest sun to our solar system. So not our sun, the next sun out. And I asked him, well, how long is it going to take for them to get there? 40,000 years. Think about it. Wrap your head around that. Now, we may very well develop things that can travel much faster than that, and we may catch Voyager 1 and 2 at some point, but that is not going to happen anytime soon. And so the moral of this story is this. This is our planet. This is our Earth system. We have to take care of it because we're not all getting on a big spacecraft and leaving.